Last little bit, let's talk about word problems. So everybody focus up here, phones away, all that stuff. So whenever you do linear equations applications, there's really only two different kinds of problems you get. I want to help you understand why they're different. So let's take a look at this one first. Sometimes you get problems like this. This is a good example. A cab ride costs $4 plus $1.75 per mile driven. They want us to write an equation to represent the cab fare, and then do something with that. Okay? So there's one example. Here's another example. Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost. Okay? So two different kinds. They seem pretty similar, right? Does anybody see anything different about that first one?
There's
Okay, so what do you mean by that?
for the initial fee is
Oh, okay, good. So we're starting to see a pattern here. Look at this one. There's an initial value, kind of like a start value, and then what about that? What is that?
Agreed.
It's $1.75 per mile. When you hear something like you hear the word per in there, you're thinking, okay, that's a what?
X.
Well, it's gonna be times X maybe. But what do we call that when we've got something like $1.75 per mile? I've got a unit per unit kind of a thing, dollars per mile. Remember, it starts with an R. What do we call that, Matt? Close. No. Rate. There we got it. It's a rate. It's a rate, right? So you get that's a rate in math. A rate is when we've got like an amount per something, right? Like in this case, it's a cost per mile driven. And so in order for us to find the amount of money that we're paying, we're going to have to multiply the rate by a distance or something, right? Does that make sense? So rate, we can recognize a rate because it's always going to be a unit divided by a unit, and usually it includes the word per in it. Miles per gallon, something like that. Miles per hour, right? Dollars per mile, right? It almost always includes the word per, which means divided by. And that corresponds to a rate. Well, what does a rate equal mathematically? It's a slope, right? So when we see a rate like that, we know that we want to put this into slope-intercept form, right? We know that the form that's going to work for that linear equation is going to be slope-intercept form. And if we write out slope-intercept form, let's just analyze slope-intercept form for a second. Y equals mx plus b. We said that m is the slope, so that would be like a rate, isn't it? Like if we're doing a word problem, we always know that's going to be the rate. What about b? Sylvie kind of already hinted at that. What's b in that case? Think back to Algebra 1. That's what we call the start value. We probably called it a start value. Does that sound familiar? Start value or the initial value, or sometimes we call it the fixed cost, right, or the fixed value, something like that. Isn't that what we got going here? We've got a cab ride costs $4, no matter what. No matter how far you go, there's going to be this $4 fee, plus there's going to be this hourly rate, right? $1.75 per mile driven. Okay, so that's going to fit into this slope-intercept form thing, right? So it says write an equation to represent the cab fare and define your variables. So what do we want to call? We're trying to represent the cab fare. We want to write an equation to represent the cab fare. So that means that the output is going to be cab fare. Well, what variable do we want to assign to cab fare? You can just call it y if you want to, that's fine. So we can say y equals cab fare. Or we could call it c or f or something crazy like that if we want. It doesn't matter, we can change the variables, no big deal. And then that's going to be the output variable because that's what we're representing with the equation. What's the input got to be?
175.
It's going to be, yeah, but what is the thing that we're going to be inputting into the function? Like we could call it x if we wanted, right? Maybe you want to call it x, but what's x going to equal? What's it going to be? The miles, yeah. And how do you know? Because it's always going to be on the bottom of the rate. Whatever's on the bottom of the rate, That's gonna have to be what we're multiplying the rate by. Always, every time, right? And so x is gonna be distance in miles. That's gonna be our input, right? So now let's write the equation. Okay, well, we're just gonna write it in slope-intercept form. So the cab fare equals the rate. What's the rate in our word problem?
175.
175 times the input variable, which we called x, that's the distance in miles, plus, what's our, plus 4. There it is. There's our model, right? Okay, and so what about part B then? If Clay's destination is 17 miles away and he has 30 bucks, will he make it? How would we know?
Plug in seven.
Plug in 17. Let's see what happens. If I plug in 17, I get y equals 1.75 times 17 plus 4. That's going to give me, let's see, 1750 plus 375. So that's going to be, what is that going to be? 3375, something like that. So does he have enough?
No.
He doesn't have enough, right? So he only has 30 bucks, he's gotta walk. Sorry there, Clay. Not enough there. So what about the next one over here? This is different, right? Does this have a rate? No, right? In this case, like in this last one, they were different. The two numbers we got, one of them was a fixed cost and one of them was a rate. They were different things, right? So that's telling you it's M and B are different, right? They're different kinds of things. But in this case, the numbers we're given are both just bags of stuff. So they're on equal footing, right? They're just different amounts of potting soil versus mulch. So this one doesn't fit slope-intercept. Slope-intercept, right? This one, we'd have to use like a standard form, right? So standard form, remember, was AX plus BY. And I'm going to put the C on this side, because when it's an application, usually you got the C is going to be the overall quantity that you're calculating, okay? And so what do we got here in this case? Write an equation to represent the total cost. So the total cost is going to be the output variable. What are we going to call that? Whatever you want to call it, doesn't matter. We'll call it C for cost. Total cost. Okay, now what's the information that we're given here? He's buying 3 bags of potting soil and 10 bags of mulch. Well, in order to calculate the total cost, what do we have? What other stuff do we have to be able to input? What other information would we need? In other words, what are the unknowns that we're trying to find?
Cost per bag.
Cost per bag, right? We'd have to know how much is a bag of potting soil, so I know how much 3 bags costs. How much is a bag of mulch, so I know how much those 10 bags cost, and if I add them up, I'm gonna get the total cost, right? Okay, so my other variables must be something like, how about P for potting soil? So P is going to be the cost per bag for potting soil. And M, I guess, is the cost per bag for mulch. Okay? And I want to come up with an equation then for my total cost. So I've got C equals, well, what about the 3 bags of potting soil? What's going to be the part of the equation that represents the cost of the 3 bags of potting soil? 3P, right? I've got 3 bags, and the cost for each bag is P dollars. So wouldn't that just be 3 times P would be the total cost? Number of bags times the cost of 1 bag, right? So we get C equals 3P, and remember, all that means is cost of the potting soil. And it's cost of all 3 bags, right? Plus What about the mulch? 10M, right? Good, we're gonna get plus 10M, and that's gonna be the cost of our 10 bags. Of mulch, and altogether, that's the total cost, isn't it? See how that works? Okay, so it's always gonna kinda be like that, right? If it doesn't, if we're not given a rate and a fixed cost, then it's gonna, the only other kind of linear equation application you could get is something like that. Right? And then what would I do if Josh spent $40.91 and mulch cost $275 per bag? The question is, how much was a bag of potting soil? Right, so we're trying to solve for what variable? P, yeah, we're trying to solve, in other words, that's asking us, P equals what? Well, we can plug in some numbers. Where does the 40.91 go?
Cost.
Cost, okay, good, so that's going there, isn't it? 40.91 goes there, how about the 275? That's, say it again? M, yeah, good, so there's, and if I plug all that stuff in, I get the equation 40.91 equals 3P plus 10 times 2.75, right? And all I've got to do, thank you, all I've got to do is just solve for P, right? Well, what is, if I multiply 10 times 2.75, how do I multiply, if I multiply a 10 times a decimal, what do I have to do? Move the decimal one place, right? So I'm just gonna scoot it over one to the right, and I get the equation 40.91 equals 3P plus 27.5. What are the two steps to solve for P? That's all we're trying to do. Subtract, and then divide by 3, and we got it, right? Okay. See what I'm saying? Piece of cake, all right? So if we do that, those go away. What's that going to give me? 1341 equals 3P. And if I divide each by 3, what are we going to get? P equals 4.47. We're done. We're about $4.47 per bag. End of story. Okay, make sense? Okay. Man, you guys actually have 10 minutes. That's pretty good. Nobody else got any time today. You get a little bit of work done. Yep.